So this is illustrated app development. I'm Ben Marx, I'm lead engineer at Bleacher Report. To give you a little bit of background about myself, I was a Ruby developer for 3 or 4 years. I've always been interested in functional programming. I tried Scala and Clojure, and I never really clicked with them for whatever reason. And I never have used JVM. So for better or for worse, it was really hard to work with those for me. My background is in computer science. It's actually in philosophy and economics. And so in the logic classes and the philosophy courses, we would prove these theorems, and the way we would do that was with functions, and which closely mirrored functional programming in a lot of ways. So for those of you who don't know, Bleacher Report is the second biggest sports platform in the world behind ESPN. As you can see, we have very high traffic and a large number of app downloads. As with most media sites, you want to be the fastest, and this is very important. And our concurrent users, the highest peak was when LeBron made his decision, I guess about 4 or 5 years ago, to go to Miami from Cleveland. And every year, the NFL draft is our biggest consistent night. One thing with all media sites is that you have to be prepared for unexpected breaking news. And we send tons of push notifications, over 3 billion notifications a month, and I'm pretty sure that's increasing month over month. Bleacher Report is about 8 years old, started with Rails 1.x. It's a monolith like most things were at that time. At that time, mobile traffic wasn't a big deal. People were going to the website for the majority of the time. And 8 years at a company in Silicon Valley or the Bay Area is a very long time. So with a Rails site of that age and that complexity, there's a lot of lost domain knowledge. And the shifting trends were from web to mobile. And things started to fall over in the Ruby world, especially with the way that breaking news notifications. We have to be the fastest, and obviously this isn't Ruby's strength. And we had to, in order to sort of cope with some of the deficiencies of Ruby, we had to invest in all these caching strategies, and they're very complex, and they worked most of the time, but when they didn't work, they failed pretty bad. And one way to make Ruby faster is to add more servers, and this isn't really a sustainable approach over time. Also, the initial appeal of Bleacher Report was that you were able to follow your local teams. At the time, we were the only company doing that. So you could, if you lived in Minnesota and you wanted to follow your local college team, you could do that. ESPN, other sites like that didn't offer that. Now that's sort of a standard thing, but that's due to Bleacher Report. And because of this on-the-fly content delivery, it was hard to cache the actual content itself. So if you follow 12 teams and the other person follows 15 teams, it's very difficult to cache that. Especially with the growth of fantasy players and fantasy football, people want to follow individual players. So then you have 50-something players per team, which you follow 10 teams and these kind of things. You end up having each person end up following loads and loads of players. And I'm not really, like Andrea as well, I'm not really a sports fan, but these technical problems are very interesting and they're very hard to solve. And so we started to look at a new language, and that was obviously Elixir. The initial appeal was that it was driven by Jose Valim, who is well respected in the Ruby community and the Rails community. And you had the Beam, which has been around for, I guess, almost 30 years, and it shines in a multi-core world. And at that time, about 2 years ago, if Elixir had fallen off, we could always write Erlang if necessary. So it had a fallback strategy. The syntax of Ruby is comfortable for Ruby and Rails developers, and Elixir looks very similar. It would have been a lot harder to sell had we said, okay, so now we're going to use Erlang. This is very different than Ruby. So you have to learn the functional programming concepts as well as the Erlang syntax. So at least you can sort of trick people into saying, hey, look, this looks like Ruby. You know the syntax. You understand this. And then you learn the functional programming concepts over time. And so this talk is about the first app that we wrote at Bleacher Report. And like every other app, this follows a common pattern. First, you have product requirements. Then you have the initial development. Features are added. And you release, you refactor, features, release. And this is a common pattern for every single app probably out there. And for this app, this is sort of the graphical history of the app. On the top is the additions, and this is taken from GitHub. On the top are the additions, and on the bottom are the deletions. And you can see the phases divided there. exploratory definition, release, features, refactor, features, and so on. The reason this is a little different is because we were looking for an alternative to Ruby. So the exploratory phase comes before the definition. And I'll explain that a bit more as we go on. So the exploratory phase, we started off in October of 2014. So this was 1 month after Elixir reached 1.0. So we at least waited until Elixir was 1.0 before we started developing with it. The code, to be clear, this was before I was at Bleacher Report, so all of this is second or third hand knowledge. So I'm going to go over this a little bit quicker, and I'll go into the other parts when I was there in a bit more detail, but just to give you a picture of the full life cycle of the app. We had a very simple data model at the time. At that time, Bleacher Report had very few content types in the app. So you had articles, videos, video articles, and that was about it. So it was a very simple model, which at the time, this was also Ecto 0.2.5. So it was a very, very early version of Ecto. And the full relationships hadn't really been defined at that point. And the relationships that had been defined, because we were new at this, we didn't take advantage of them all the way. So we ended up using JSONB to sort of cover both sort of the early versions of Ecto, and as well as our own sort of inability, or not ability, as well as our own sort of learning curve. You know, if we don't know how to do this exactly, we'll just throw it in JSONB, and at least it's in a database, and that would come back to bite us later. And you can see this is sort of the additions and deletions graph, or what you'd expect for a churn of a new app, especially with a new language and a new framework. Lots of the initial commits were like, maybe this works, maybe this works. Is this better? Is this better? And as Andrea mentioned earlier, we used enum a lot, which was very inefficient because it's eager loading, and we figured that out later on. But despite all of this, it actually performed quite well, and it showed a lot of promise. And the first version of Phoenix we used was 0.4.1. You can see there are no guidelines yet. Do what feels natural, submit a bug, join a discussion, open a pull request. This is a pretty laissez-faire attitude to have towards a framework, especially when you're building the core part of your business around. And also, using CoffeeScript in Phoenix is very strange. But if you scroll down to the bottom of the page and you look at the roadmap, most of the initial core features were already developed. And so even though the development guidelines weren't there, at least the features were, the foundations of the features that have made Phoenix today what it is are there. So the next phase is the product definition. So we realized, oh, look, this actually is something that could work. The developers seemed to like it. We actually started writing a second app. And the second app was making a translation layer for the older and newer apps to talk to the newer apps. And you can see in this time that nothing happened, basically. Part of the reason was because we had to figure out, so we have this 8-year-old Rails monolith. How are we going to break this apart into services? And a lot of the knowledge was lost. If you look, the Ruby code wasn't documented very well. There weren't many people there who knew what was going on. And it was quite of a difficult time. And you know, part of this breaking apart this monolith was understanding that we were going to end up doing things wrong, and that we were going to have to go back and redo them. And the product and stakeholders supported that. And this was Ecto 0.5, which Ecto change sets were introduced. And this was, in my opinion, the single biggest change to Ecto Phoenix ecosystem that makes introduction to functional programming in Elixir. And I'll talk about this in a bit more detail when I talk about the code change over time. But we were doing something like this before. And it was sort of a convoluted way where you take a map and you turn it to a struct, and then you would update it. And it wasn't predictable, and it was very sort of messy. But again, it worked. And the next phase is the release phase. And this is actually when I started. So now I can talk a little bit more detail about the phases themselves. So because we had stopped development for about 4 months, we were, I think, 3 or 4 versions behind Phoenix. And one of the great things about Phoenix and Elixir in general is the great documentation they have, and especially in these early stages when you were upgrading, there was an upgrade path. And still today, when a new version of Phoenix is released, they say, these are the steps you do, and tick, 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 you're done. And we are so far behind that the latest version that they had was versions before us, or rather after us. So it took us like 2 or 3 days to get up to speed. And I vowed from that point on that we would always stay up to date no matter what. So if a new Phoenix release came out once a day, we would update it and move on. New Ecto, update it, move on. And this helped us to get into a pattern of refactor as integral part of development. This should be done regardless, but especially with a new framework, a new language, understanding that refactoring is going to be crucial to keeping up to date and to improving your code is essential. And also from the fact that we had this monolith and that no one liked working with, and it was, it's code, 8-year-old code, we wanted to make sure that that didn't happen with the new stuff with Elixir and Phoenix. And at this point, we had 3 Elixir apps, and within the first week, we had this, I wrote an Elixir app, and I didn't really know anything about Elixir until about 2 weeks before I started at Bleacher Report. Just by happenstance, someone that I used to work with said, hey, we're using Elixir. And I was like, what's Elixir? This is very interesting. Erlang, I've heard this is sort of an esoteric language. This looks interesting, looks like Ruby. Maybe this could be the functional programming language that appeals to me. And this was actually this was the reason I joined Bleacher Report. And it was actually really nice because we had this older Ruby app, and it didn't perform very well when it had to do multiple things at once. So, it's very simple. It does one thing, it fetches data, manipulates data, and does these things. And I was like, I'll just try rewriting this in Phoenix and Elixir to see if I can do this. And it took me about a day to rewrite it in Phoenix and Elixir. The code, I look back on it now, for this presentation, I was like, oh, that's bad code, but it worked. And the funny thing was that it outperformed the Ruby app, many times over. So to give you sort of an approximate idea of how the Ruby app fared, if you tried to fetch 5 links, it was like a second. If you tried to fetch 10 links, it was 2 seconds. If you tried to fetch 15 links, it was 6 seconds, and it was an exponential growth until it just eventually fell over. And the exact opposite thing happened on the Elixir app. There was incremental time. So you fetched 5, it was half a second. You fetched 10, it was maybe 3/4 of a second, and so on. And then we could actually, I think it was around 50 links before it started to fall over, but this was a use case that we would never have. And then the release itself was a phased release. So what we did was we started off with the least popular streams like dressage or equestrian or even like WWE type stuff. There were safe bets that we could say, if something happens, we have a small number of users that use this, and it's okay if it breaks because chances are no one will even notice. And it took us about 4 months to get that to where we were able to migrate all the streams, and we did that with rollout flags. So in the event that something broke, flip it back, it'll go back to the older system, and it was fine. And if you look at the graphs, the additions and the deletions, again, this is what you would expect from sort of an immature app. Lots of changes, lots of churn. And at this point, we were still using, even though change sets had been introduced, we weren't using them. We were still just directly inserting maps into the database, or structs rather. And it wasn't until a few releases later that Ecto would say, you can't do this anymore. We can't guarantee data integrity if you do that. But at this point, it was still OK to not do that. And this was the period from about May to October. And this saw milestones in Ecto, Phoenix, and Elixir. This was Ecto 1.0, Phoenix 1.0, and Elixir 1.1. So at this point, we could be fairly confident that the APIs were stable, that we wouldn't have to do these major upgrades and so on, and that we, as a company, felt that Ecto and Phoenix are the way that we want to go. And Elixir had already been stable, but we were very pleased with the way things were going. And from the stakeholder point of view, it was a performant app. It was doing much better than the Ruby app. And this is credit to the Beam. The Beam does a great job of covering up your mistakes and of writing poor code. So this gave us the confidence to continue iterating over it. Some of the negatives, it was still very object-oriented. We were all Ruby and Rails developers. We didn't have an Erlang expert or any other sort of functional programming expertise. So if you look at the code, it still looked like a very Railsy app. We had even an interactors directory, which was a Rails and Ruby thing, and they're basically a service class if you've never used them before. They don't really belong in a Ruby app, yet alone an Elixir app. And then at this point, it was quite difficult, especially when using Erlang libraries, to deal with dependency resolutions. Because if you would, one library would use, tag head, one would use 0.5, one would use 0.5.0. So the mix.exs file had all of these different override true, override true, override true, and I mean that's obviously improved quite a bit, but it was a difficult time at that time. And in the Ruby world, you have New Relic, and I guess also some other, I think the Go and Node as well, where you can basically get all of your monitoring done. It's very easy. It's a service. Everything's done. And we, as a Ruby company, had used them. I think our ID is in the top 50 or so. So we've been using them for a very long time. And and there obviously was nothing like that for the Elixir world. But we found Exometer, which is a metrics library for Erlang. And this was actually quite a difficult library to deal with in terms of dependency resolution. But we got it working. And one of the remarkable things about working with Elixir and the Beam is that we showed these charts and the metrics, and we're like, this is crazy. Like, we must be doing something wrong. Like, no matter the traffic, the CPU use is at 3%, the memory use is at 3%. Nothing seems to affect this app. We must be measuring these things wrong. And at this point, before the release itself, we brought in Erlang Solutions to just sort of say, hey, we're all new to this. You were working with Erlang for years and years and years. So can you just let us know if we're doing something right or something wrong, and how we can improve? And it was actually very reassuring because they're like, no, you guys are actually doing things really well, and they're very helpful in explaining how the Beam works and with the schedulers. And at this point, the documentation for sort of intermediate Elixir was pretty lacking. And even stuff like, we didn't even know that the observer existed. And so they showed us observer.start, and it's like, oh, you have all this stuff built in. This is amazing. Now we can see all these things locally. And using these kind of things, we're able to understand how the schedules worked and all these, and this. So it made life a lot easier for us. And it turns out that the CPUs and memory use aren't really ways to monitor things in the Elixir and Erlang world. And so once we released it, it went on to production. We celebrated, hooray, we did this thing, and it's working well. The next stage was features. And part of the problem with not developing features for about 8 months was that the product team is antsy to have these features that they've been waiting for to be developed. And at this point, we had three Elixir apps in production, and on the Phoenix, Elixir, Ecto side of things, there were no major releases. And so feature development had been on hold for 6 or 8 months. We had a big backlog, and part of that backlog, part of the promise from the Elixir side of things was that we had the product team had all these different kind of content types that they wanted added to the app. So Instagram, Facebook, tweets, and all the various other things. And because of the data modeling choices that we made earlier, it was very difficult to, one, add these, and two, it was non-trivial work because we were still thinking in terms of models. So instead of thinking of things, for example, as change sets, we thought of a tweet as a tweet model, and Instagram as an Instagram model, Instagram video, and it became very cumbersome and slow and lots of data migrations and very messy. And because of the decision to use JSON-B, it was very difficult to validate them, because then you had to take that and transform it from JSON to a map, validate the fields, and so on. And we were essentially losing out on all of the built-in model validations in Ecto and Phoenix. And you can see the humps there as we started adding more and more content, and it wasn't sustainable. So the next phase was refactoring. This was perhaps the biggest, other than deciding to use Elixir and Phoenix in the first place, this was the biggest decision and the biggest undertaking that we had to do. You can see these charts are quite remarkable and striking. And it also was sort of a time of experimentation. I think I've been doing Elixir for about 6 or 7 months now. And the first giant spike is when we started just adding content types as models, and then it was doing this very sort of difficult way of metaprogramming. And it was like if you it would have been very difficult to get a new Elixir programmer and say, look at this code, what does it do? It was very unclear. And it wasn't, it was like, this isn't going to work, we have to figure this out. And so we decided to redo the data modeling. So before, a stream had many items, and that was it. It was just one layer. And the way we decided to do it afterwards was that a stream has many items, and each item has one content, and each content has one metadata. And the way that we saw that was that the content was basically mutable data that the programmer, like the content programmer, would add. So it would be like a title or a description or a thumbnail or a video, depending on the type of content. And the metadata was data that didn't change: author name, provider URL, provider name, these kind of things, stuff that wouldn't change over time. And the way that we did this was that we keyed off a content type. So each content type had a unique key, so whether that was an article, video article, and so on. And it made for a much more declarative way of developing, as opposed to saying, well, maybe this is this content type because it has this key, or so on. It said, I'm this content type, validate me as such. This was also during the release candidate phase for Ecto 2.0. And this is another interesting change in the Ecto landscape, where before you were validating on a model, and then they changed it to data. And this was also a very small but very intentional change that helps me to sort of understand how to look at data or models in the functional world. And that it's not a model, it's just a collection of data, and you transform it, and then something else comes out the other end. It's either valid or not, and so on. And this was something that touched the legacy app in a way that we'd never done before. This was incredibly difficult to deal with. The only way that we could get it to work was by having a shadow production environment and having a production environment, because we have offices in San Francisco, New York, and London, so we don't really have a downtime. And there's sports usually going on all over the world, or there's never really a downtime. So it was very difficult for us to just flip the switch and hope it worked. So we ended up having to go back and forth on this shadow production and production environment 4 or 5 times. And you would get sign-off from the app team, from the web team, and so on, say this looks good. We'd flip it, they'd be like, oh, this field that no one knew about is actually causing everything to crash. So the Android app isn't working, so we flip back. And it was a very difficult time, not a lot of sleep for a few days, but eventually we got it to work. And we really had a lot of support from our product team and our engineering managers, and Dave Marx, who's our senior director of engineering, was incredibly helpful in saying, it's okay. If it doesn't work, we'll do it again. And it also sort of gave us the confidence to keep going and to figure that we'll get this right eventually. And we did, and it paid off in great dividends. So here's an example of a new content type. So on the right, you have the insert change set and the cast change set. So you have the top level, which is the stream, and then the stream has content, and the content has a metadata. And so on the arguments for the function are the model, but this is before Ecto 2.0, so it's still model params and the content type. And then you pass in the content type into the cast change set, and then it casts that based on the various fields. So we were able to only have 3 tables, and I think we have now about 15 or 16 content types. And what took a day or 2 before to model now takes an hour or 2. And this is actually a very good way for new developers to start working with Elixir, because one, it gives them an idea of how change set works and how to model data in a functional way. But it also gives them a sense of accomplishment, and in a very easy way to do that, because this is something that's very obvious in the app. You can say, look, I did this little piece. Now we have this new content type. Now we have a tweet. Now we have like a podcast or whatnot, and it's very easy to test as well. So this was the biggest. This was the sort of the keystone on which we base all of our new development on, and it made life a lot easier, and it was essential to developing our backend team to be Elixir developers. And at that time as well, standardizations had not really been around in Elixir. I mean, there were various style guides online and this and that, but we didn't really have an Elixir style per se as a company. And there were a few different libraries that came out. Dogma was one, and that was just a basic linter. It says this is wrong, this is wrong. You're missing a space here, and this and that. And we found Credo, which is a great tool, because on the right it tells you why, and then you can actually go into if you run Credo on the actual line, it'll go in and give you like a full page explaining why this is not an optimal solution. And it's really great because it makes code reviews that much more meaningful, because normally, I don't know, when you review code, if you see that there's this extra space here or that, those are obvious and easy things to get out of the way. So you're like, okay, I reviewed your code, I have these small changes to make, and it's really a superficial code review. But if you use a tool like Credo, which takes care of all the superficial stuff for you, then when you review the code, you actually have to look at the code. You have to look at the flow of the data. You have to look at the architecture of the pull requests and so on. And it makes the life a lot easier. We use X coveralls as well to make sure that we have high test coverage. And EnchX, which is the Elixir version of Ench. Both Credo and Ench are written by Rene. R-E-N-E, I think, is his GitHub handle. And I can't recommend them enough. And the nice thing about having high test coverage and then having these documentation, using Ench for documentation, and Credo for these simple superficial code reviews is that, and also the fact that Elixir is a compiled language, it allows you to refactor big chunks. Like it'd be very difficult to do this with Ruby because it's a dynamic language, and if you there's no compiler to say this is wrong or this isn't going to work. It allows the developer to move code around freely, and to think of terms and functions and modules instead of thinking of models and these kind of things. So this led us to have consistent code style across all of our Elixir apps, and this was really the way that we were able to onboard our developers to Elixir. And after this stage, we had another stage of features. At this point, we had 4 Elixir apps and 2 more in development. The most significant of these new apps was our push notification service. As I said before, we send, I think, 3 billion push notifications a month. The older push notification library service was written in Ruby, and we had these external workers, and there was all of these various caching mechanisms, and it was very slow. So depending on the number of subscribers, so if you're subscribed to NFL and say the New England Patriots, and you send a message to both, you obviously don't want to receive 2 messages, so everything has to be deduped. And in Ruby, this was very slow. So depending on the number of subscribers, it would take from 1 to 5 minutes. And with the new version, with the Elixir version, it was very simple. There were no external dependencies. It was gen servers, and it was gen servers, so it was very easy to reason about, and we were able to get rid of this third-party service. And the most meaningful thing was before it would take a minute to 5 minutes, and now when the content programmer would push the button to send the alert, they would immediately get the notification. So this was a demonstrable win, both in terms of saving on third-party libraries, in terms of servers, in terms of server costs, and as well as being able to have competitors' apps on your phone and game ends, and your notifications are consistently fastest. I mean, this is a win across all areas of the company. And so the NFL draft, as I mentioned before, is sort of our yearly. We can guarantee that this is going to be the busiest night of the year. And this was the first year that we'd had our Elixir apps in production. And in years past, it was sort of a nerve-wracking night because we had all these auto-scaling rules in place for the Ruby apps, and in years past there had been some rocky times and so on. And so this year, we were all sitting at the office watching the draft go by, and we were wondering, is this going to be okay? We're all nervous, felt fairly confident, and from looking at it from a metrics standpoint, nothing changed. The metrics were flat. It was just like any other day, which is really amazing to see. And nothing happened. It was a calm night, so we just ended up sitting around talking, and it was a win across the board for that. And the only sort of hiccup we had was one service that was still using Ruby, and because of this caching with Redis and these kind of things, the developers ended up having to manually flush the cache over and over to make sure that it would keep updating. But other than that, it went fine. And then with unpredictable traffic spikes, during Kevin Durant, he joined the Warriors, and this was huge news, unexpected news. The traffic spiked in 4 minutes, and again, on the Elixir side of things, nothing changed. It was remarkable. So that was just another testament to how well Elixir is working for the things that we needed to do. And the final thing that we had done on the feature side was to move all of the list blending to one app, and this was part of this was understanding the architecture that we had and understanding how we wanted to take the monolith apart. So the last big piece of caching problem that we had on the NFL draft night was basically when you open the app, you get your blended streams, and that we had cached with Redis. And so we moved that into the main app that we were using to do all of the list management and these kind of things. And it was the most hit endpoint in the system. So we were a little nervous again about, is this going to work? And it performed remarkably well. And there was obviously an increase in traffic because we weren't Fastly. We use Fastly to cache the streams that we can using surrogate keys, so that we only get we have about a 90% hit rate on Fastly. So with the new blended streams, we weren't able to cache that, and you can see here what happened. So before we were getting very few actual hit requests to the Elixir side of things. So part of this was the efficacy to which we were using Fastly, and then on the right, the spikes are when we moved the homepage of the app to the Elixir app as well. And now we get about a 50% hit rate, and this is about a daily. This is daily sort of traffic, or it's not daily, but I mean you see the wave patterns that we get over day, and this is the response on the Elixir side, and it's pretty remarkable that it doesn't change at all. There are ways that we can improve this. Since we use Docker to deploy, and each of our apps are isolated in containers, we can't really use ETS tables because each ETS table is only for the container itself. But this is something that we're improving over time, and we'll get there eventually. And this is, I can't stress this enough, encourage iteration. We wrote sort of suboptimal Elixir code in the beginning, to say the least. And over time, we still are iterating over each app, and each Ecto release, each Phoenix release is a time for us to sort of evaluate the code and to find ways that we can improve and write better code. And I'll show you some examples of that. So with Ecto change sets, as I said, this is a huge part of how we came to understand Elixir and Phoenix in a good way. So this was the first one. I showed this before. We take a map. You get the track from the map. You get the struct, and then you just update that into the database, and then you return the track. And this was after Ecto change sets were introduced. You have a change set, you have a model, you validate it, and it returns it. And at this point, this was after Ecto had said if there's no change set, we can't guarantee data integrity. So we did the bare minimum to please Ecto. Here's the next iteration. So this is much more indicative of what you'd see in a more mature Elixir app. So we had the top level item, the content item, and then the metadata, and then the content. All of these were wrapped in a transaction, and so you would validate all of these various fields. So this was the way that made sure that it was a valid content type, made sure that the URL based on the content type was valid, and lock the position, doing all of these things that we would have done in callbacks or elsewhere in the application, in the Ruby world would have done. We managed to do this all here in one place. And this is the current implementation. So this is very similar to the other one, except that now we have figured out that you can do this cast-associated content. So we're able to basically do the same thing without the extra boilerplate of wrapping it in a transaction. So you validate all the fields, cast the associated type, and validate all of those fields. And if those all pass, then the data is inserted. Another element that we worked that was sort of a selling point of Elixir was the ability to do a lot of things at once. So for instance, if you need to add a piece of content to all NFL teams or all soccer teams or all NBA teams and these kind of things, this was very slow. And there's 32 NFL teams. I think there's about 700 NFL players. There's a couple thousand soccer teams or football teams if you prefer. And then I think there's about 7,000 European football players. And this was incredibly slow. It would time out. It was very unreliable. And here was our first go at it, and this was pretty poorly done. But as Andrea mentioned earlier about the difference, this is eager loading. So basically it would do all of this and then do all of this and then it would flatten it. And using task and async and await there was pretty unnecessary because it had to wait to finish this before it would go to the next one. So, but this was still actually better than, this is a pretty naive implementation, but it was more performant than the Ruby version. Here's the next version. This was sort of something in between where we start with a stream and then unique, which just doesn't make sense, and then go back and forth, but it was better performed as well. And this was also, this was before we decided we were using change sets to validate content, so this is sort of, it's not a very confident way to model your data. Make sure that, well, is this actually unique? If you're doing bulk updates, you have the same ones, and then make sure, filter these out. Like, these are things that should have been done in change sets that we were trying to sort of artificially insert into this create track interactor that we had. And it worked, but as you can see, we were not really benefiting from the Ecto change set or from the Phoenix validations. And this is our current implementation. So basically, it chunks based on the size of the number of playlists that you're trying to add to. So playlists are the streams, is just the internal name we have for them. And then it creates them and creates the tracks in there, and then it returns it at the end. Then this actually worked out pretty well because we're based on the length of the list, where the chunk size changes. So what before would take, if you wanted to add a track to all soccer players, it would take 15 to 20 seconds, and it would time out, it was very unreliable, and now it takes under a second. And the chunk size is based on the link, so if you only add to five streams, then the chunk size would be smaller. If you add to 1,000, it's different. So it actually worked out pretty well. And we can actually add to all streams in under about 5 seconds, but there's never a need to do that. It's just sort of a use case for us to see. And so here's where's Elixir Bleacher Report. You've seen sort of how the development of one app has sort of spread to the development of other apps and really to adopting Elixir Bleacher Report. So now we have six Elixir apps in production. We have 3 more in development. And it's kind of interesting the way that we've decided to sort of break out the monolith, because we do it on a sort of need basis. So the first one was when it was falling over with the list merging, and then the next one was the app that I wrote, and that was more of an experiment for me to see if I can write Elixir. And then after that was the push notifications, which was a huge win for us. And now we're sort of starting to break apart the internal tools, like the writer tools, the way we generate articles, the way we generate sort of our tag hierarchies. That's our sort of next steps. And we've bet on Elixir so much that all new consumer-facing apps have to be written in Elixir. We have Ruby developers who, for whatever reason, everyone can write Elixir, but some sort of prefer Ruby. It's comfortable. So if they want to write a Ruby app, it has to be an internal-facing app, an admin app, a card app. So you're sort of limiting yourself by writing a Ruby, because you're not going to be, the general public aren't going to use the results of your code. The stakeholders are very happy. We have tangible benefits. This is very easy to show. Server cost, we're still over-provisioned on the number of servers that we use, and this is just sort of over time we're fine-tuning it. But I mean, we saved quite a substantial amount of money on servers, and third-party integrations as well. For the push notifications, we're using these third-party to sort of to send out the notifications, and all of that is done in-house now. So it's really rare, I think, to have developer happiness, to have stakeholder happiness, and to have product happiness, as well as increased productivity. So this is a really easy sell, I think, if you're considering Elixir and Phoenix. And then Gary Barnhart posted this the other day. Finally learning Phoenix. The docs are good, and Rails with a lot of the magic removed definitely feels accurate so far. And I think this is a good selling point for Phoenix. I don't know that the Phoenix team would agree with that, because I think that they're doing something different than Rails. But it's definitely a good sort of siren call to Phoenix that says, Rails, you're doing this, it's familiar. But instead of there's a sort of, in the Rails world, automatically doing things. In the Elixir and Phoenix world, that's removed. You have a con, you pass it around, you manipulate it, and you return it. And I think that leads to better developers and to better development when you understand exactly what's going on. I mean, there might be a little bit more boilerplate, but I think the boilerplate is worth it when you actually understand the transformation and the manipulation of the data. And also as Ecto moved away from models to data, Phoenix 1.3 is moving away from having models to having everything under the lib directory and from models to modules. So I think it's an exciting time to sort of, and both an exciting time to be working in this ecosystem, but also for people on the outside to join. And so finally, a summary of where we're going from here. All of our backend developers can write Elixir on this app that I've been showing the graphical history of. There have been 16 contributors, which is more than backend developers that we have. We've had some ops people make contributions, we've had some front-end people make contribution. It's sort of been both a experimentation pool and also as an introduction to Phoenix and Elixir. And it's enabled us to make all of our developers be able to write Elixir. And even the front-end developers are sort of interested. There's sort of a revitalization of the developers in the sense that here's a new language, here's Phoenix, here's Elixir, try something new. And they see it's very rewarding from a development side of things when you say, hey, here, look at this, I have done, we wrote this new code, now we're using, X many less servers, we're saving this much money, this makes me, as a developer, I feel really good about this. And the front-end people are like, this is really interesting, I want to try this too. And, the way that we sort of introduce new developers is we give them the programming Elixir book, you learn the syntax, learn sort of the standard library, and then we take an existing project and have them do small features, and as mentioned earlier with the standardizations, that helps them quickly become pretty decent Elixir developers pretty quickly. And we started sort of open sourcing our internal tools, so look for more of that from the Bleacher Report account. And we're sharing our experiences at our dev blog, so dev.bleacherreport.com. We cover many topics, but you can see how we're writing sort of more Elixir-based stuff because that seems to be more interesting to people. And with that, any questions?